Okay, this is going to be part 7 of the video series on trigonometric substitution. And up until now, we've been using these 8 steps to solve the problem. Now, if you haven't done it, I would definitely watch the first 6 videos just to see how to use all these steps. Now, in the problems that we've looked at so far, we started with step number 1, which is to determine which of the 3 forms that we had. And remember, it fell into one of these 3 forms. Either the square root of something squared minus something squared, or something squared plus something squared, and so on. So it fell into one of those 3 forms. But on certain problems, you're going to run across this. It will not be immediately in one of those forms, and you're going to have to use an algebraic technique called completing the square. So what will happen is that you'll have a 0 step, and it will look like this. So the 0 step says this: if necessary, first complete the square. So on this problem, we're going to have to work on where we have to complete the square before you can decide which form it goes into. So now with that in mind, let's take a look at a problem, see what a problem looks like where you have to complete the square. Okay, now the problem looks something like this. Now look at the square root in the bottom. It's not something squared plus something squared. It's just x squared plus 4x plus 13. Now you can change this into something squared plus something squared, if you remember your algebra techniques, by completing the square. So what we'll do, we'll actually add a 0 step on this one, and that 0 step will be to complete the square. So let's go ahead and we'll do that right now. So again, what we're going to look at will be a new 0 step, which says, if necessary, complete the square to get it in the proper form before we can do these other steps. So let's go ahead and try that. So in completing the square, now just remember, what I want to do is to change the expression inside the square root into something squared plus something squared. So this will be actually what we'll call the 0 step. So this is going to be step 0. Now, just a reminder on completing the square, the idea is go ahead and take x squared plus 4x plus 13 and set it equal to 0. Now this is just a plain old algebra technique. Hopefully you've done this back during your algebra days somewhere, but we'll go ahead and run through it. Now to complete the square, what you do is this: make it be x squared plus 4x, then leave a little space here, and take the positive 13, move it over to this side, and make it be a negative 13. So it'll look like this. Okay, now the next step is whatever, since you've got a 1 in front of the x squared, whatever's in front of x, remember, divide by 2, and hopefully, again, you're familiar with this technique already. So take the 4, divide it by 2, and that gives you 2. And then we'll take this 2 and square it. So 2 squared gives you a 4. And then you take the 4 and you move it back up to this side. So you put it right in here. And whatever you do to one side, you got to do the same thing to the other side. So you also add it over here. So plus 4. Okay, now you rewrite it as something squared. So looking at this, you can rewrite this, and this is the whole purpose of completing the square. You'll rewrite it as x and then plus 2 squared is equal to, and add these 2 together, and you'll get a negative 9. So again, this thing right here turns into this, so it's just completing the square. And you want to get it back to 0 again, so take the negative 9 from this side, move it over to this side, and you would actually have x plus 2 squared plus 9 is equal to 0. So what you've done here is this: you've changed it from this form into the form where you completed the square. So now you've actually got something squared plus something squared. So now with this in mind, you can actually do this. You can rewrite the original problem. So we'll rewrite it as the integral. So it'll be the integral of, and we'll make this be, put the dx right here. So you've got an x on the top, the square root, and then rather than this, put it in this form right here. So it's going to be x plus 2 squared plus 9. So all you did is just change the form. But now what that does, that allows you to have it something squared plus something squared, so it will fall into one of the three cases. So really the only thing you did there was just added a new step called completing the square. So that takes care of what we're going to call step 0. Now once you're done with step 0, the rest of the problem is exactly like what we've done in all the other problems. So we'll just run through these steps and complete this thing. So first of all, you got to figure out which of the three forms you have. And let's take a quick look at that. In our problem, we've got something squared. Now I'm going to think of this as being x plus 2 squared. And then think of this as being plus 3 squared. So we've got something squared plus something squared. Now looking at our cases, the possibilities, you've got something squared plus something squared, so it's actually going to fall into this second case right here. So what we'll look at is case 2, and you can forget about these other ones. So really, you just have to concentrate on these two formulas. So the square root will turn into a times the secant, and u will turn into a times the tangent. So now we know what the form is that we're looking at. So back to the problem. And I think we'll go ahead and turn on those formulas just so we can remember what they were. So again, the square root turns into a times the secant, u turns into a times the tangent. Now at this point, we'll go with the exact same steps that we've done in all the previous problems. So let's take a look at them. So we figured out which form we're going to go in. So now we need to change the problem from an x problem into a theta problem in steps 2, 3, and 4. So first of all, we'll take care of the square root. So on the square root, well, this will be step 2. And we'll do this one in, I think, red. So step 2 is change the square root of x plus 2 squared, and then plus, and think of this as being 3 squared, is equal to a times the secant of theta. Now in our problem, this is what we're going to call u, and this is what we're going to call a. So again, this is u, and this is a. So in this particular problem, it will look like this. It'll be the square root of x plus 2 squared plus 3 squared. And in place of a is equal to 3 times the secant of theta. So this is what it's going to be when you change the square root into one of the form of theta. Okay, next step. The next step says, okay, now you want to express dx in terms of theta. So to express dx in terms of theta, we will do this. This will be step number 3. Now you want to express dx in terms of theta, but we'll start with this. So you begin with u is equal to a times the tangent of theta. Now u is equal to x plus 2, so this is going to be x plus 2 here. A is equal to 3, and then you've got the tangent of theta. Now we'll solve this thing for x. So that means then that x would be equal to 3 times the tangent of theta, and then you'll have minus 2. So that's going to be x. But what we want is the derivative of x. So we'll go ahead and find the derivative. So the derivative of x with respect to theta would be equal to 3. Now again, the derivative of the tangent is the secant squared. So this will turn into a secant squared theta. And the derivative of a constant is 0. So that gets you to dx is equal to 3 times the secant squared of theta, and then you've got d theta here. So when you change dx, it will turn into this right here. Okay, so you've taken care of the square root, and you've taken care of the dx. The only thing you haven't taken care of is this x on the top. So the next step says, express any remaining x's in terms of theta. Well, in our problem, we've got one remaining x up here, so to express that in terms of theta, you can actually go to this statement right here. So this will be step number 4. And in step number 4, x is equal to, and in this case, you're lucky you've got it worked out right here, it would be 3 times the tangent of theta minus 2. So there is the remaining x. So in these 3 boxes are the 3 things that you need to change this from an x problem into a theta problem. So looking at our steps, and again, same steps we've used in the previous problems. Now go ahead and rewrite the integral in terms of theta. So when we rewrite it in terms of theta, we'll scoot things down just a little bit here. This will be step number 5. So what step 5 will be, you've got the integral, and then we'll have, in place of x, put what x is equal to. So x is equal to 3 times the tangent of theta minus 2. Now on the bottom, the square root is equal to 3 times the secant of theta. So this will become 3 times the secant of theta. And then finally, put all this in parentheses, dx turned into 3 times the secant squared of theta d theta. So this will be 3 times the secant squared of theta d theta. Okay, so you've got it set up. Now if you can simplify it, let's see if we can simplify some of this. So a couple things you've got a 3 in the top and a 3 in the bottom. This 3 here will cancel out this 3 here. Now you've got a secant squared in the top and just 1 secant in the bottom. So 1 secant in the bottom cancels out 1 secant in the top, but not both of them. And that will leave you with this. So this gets you to the integral of, now everything in the bottom canceled out. So in the top you've got 3 times the tangent of theta minus 2 times the secant of theta d theta. Okay, next step, go ahead and distribute this. So take the secant and distribute it to here and to here. So when we do that, you would have the integral of 3. Now, secant times the tangent would give you the secant tangent. So that's going to be the secant theta, tangent theta. And you're going to have minus 2 times the secant of theta. Theta d theta. Okay, now at this point, you can split this up into 2 separate integrals because you can find the antiderivative of the secant tangent and you can find the antiderivative of the secant. So we'll go ahead and do that. So I'll split it up from a single integral into the integral of, and actually I can move the 3 out in front here. Then I'll have the secant of theta, tangent of theta, d theta. So there's the first part of it. Then you've got minus 2, and we'll make this be a separate integral, the integral of the secant of theta d theta. Okay, so now it's just a matter of finding those antiderivatives. So what this is going to give you is 3. Now this one you should remember from your integral tables, but if the derivative of the secant gives you the secant tangent, then the integral of the secant tangent will get you back the secant again. So this will turn into the secant of theta. So the antiderivative of the secant tangent is the secant. Then you've got minus 2. And you've got a secant, but remember from your secant tables, the integral of the secant is the natural log of the secant plus the tangent. So this will turn into the natural log of the secant of theta plus the tangent of theta. And then finally you'll tack on plus c at the end of the whole thing. So if you need to, go back and look at your trig rules. But just a reminder, the secant tangent turns into the secant, and the integral of the secant turns into natural log of secant plus tangent. So that's just your trig rules. Your integral rules. Okay, so what that does, that actually gets you through, this would be step 6. You evaluate the integral. So let's take a look at our steps again. So step 6 says to evaluate the new trig integral, which is what we've done. Now the last part, you've got to change it from a theta problem back into an x problem again. And we're back to this thing where you draw the triangles and use the triangle to rewrite the final answer in terms of x. So let's go ahead and do that. Okay. Now again, first of all, in step 7, what I'm going to do is the same thing we've done in these other steps. In step number 7, I'm just going to draw the right triangle. And the purpose of this right triangle is to allow me to change the theta back into x again. So here's theta. Now, just like in those other problems, I'm going to take the time to label this is the opposite side, this is the adjacent side, and this is the hypotenuse. Now, two of the sides you'll be able to get from your trig functions before, so let's go back up to and look at the top here. What we've got is this. We're going to use this one. X plus 2 is equal to 3 times the tangent of theta. So we'll use that down here. So you know that x plus 2 is equal to 3 times the tangent of theta. So solve this for the tangent. Divide both sides by 3, and you would have this. It'll give you x plus 2 divided by 3 is equal to the tangent of theta. Now you're doing all this to try to figure out how to label the sides, what goes where. And just a reminder, the tangent is the opposite over the adjacent. So on this problem, the opposite side would be x plus 2. So you know the opposite side, this side over here is x plus 2. Now the adjacent side is 3, so this side down here will be 3. Now the remaining side is always whatever the original square root was. Well, in this problem, the original square root, and you can write it in either this form here or this form here, either one's fine. I think I'll go ahead and put it in, well, let's go ahead and put it in this form right here, x squared, or x plus 2 squared plus 9. So this side right here would be the square root of x plus 2 squared plus 9. So that's the remaining side. Well, now you've got all 3 sides of the triangle labeled, so you can use this to change these remaining trig functions back into x again. So this will finally be step 8, the last step. So you've got 3. Now you need the secant of theta. Well, just come over here and set up with this reminder what that is. The secant of theta is equal to the hypotenuse divided by the adjacent. So looking at your triangle, the hypotenuse is the square root of x plus 2 squared plus 9, and the adjacent side is 3. So this is what the secant of theta is equal to. So you can replace that over here and make this be, in place of this you can have the square root of x plus 2 squared plus 9 divided by 3. Then you've got minus 2. Now you need to change this natural log again. So this is going to be the natural log of, again, the secant of theta, but you've already got the secant of theta. We just found that, so you can use this again. So this is going to be exactly the same thing it was right here. The square root of x plus 2 squared plus 9 divided by 3. Then you need plus the tangent. Now the tangent, you can get off the triangle, but actually you've already used it over here. The tangent of theta was x plus 2 divided by 3. So you can replace this with an x plus 2 divided by 3, tack on the plus c, and you'd be done. So actually that's what the answer to the problem looks like. Now you can do one more thing if you want to. You can go a little bit further with it, and you can change these back into their original square roots, and also these 3's right here would cancel out. So let's go ahead and do one more step on this. So if you want to, now the original square root was x squared plus 4x plus 13, which is the same thing as this right here. So if you want to, you can change this back into the square root of x squared plus 4x plus 13 13, and then minus 2 times the natural log of, and again, this one you can also change into the square root of x squared plus 4x plus 13 divided by 3, and then you've got the plus x plus 2 divided by 3, and then tack on a plus c. So that's what the final answer is going to look like right there. Okay, now the only difference in this problem and the previous problems is at the very beginning, and I think I'll kind of surround it in red here, at the very beginning of the problem, and let's look at our rules one more time. In the rules, you had a new step where, if necessary, complete the square. So we had to do this step 0. So on this problem, since it was not in the form of something squared plus something squared, you had to change it into something squared plus something squared. So you had to do this initial step right here. So this step right here was the completing the square to put it in a form that you can apply the rules to, and then you do the rest of the problem. So there's a first problem using completing the square. Now this one had this. This one had a positive x squared. We'll do one more example in the next video where you have a negative x squared, and that will change the entire answer completely. You have to go about it a little bit differently. So anyway, there's an example of trigonometric substitution using completing the square.